Hello, welcome back. Let us continue solving past model exams on matrix, probability and vector. The first question: if the matrix A given here, a 3 by 3 matrix, then what is the determinant of A transpose times A? The determinant of A transpose times A is equal to determinant of A transpose times A. We can decompose. And remember, determinant of A transpose is equal to determinant of A. Therefore, this is equal to the determinant of A square. In place of determinant of A transpose, if you write determinant of A, since they are equal, when you multiply it will be squared. So now we can find the determinant of A and then square it. The determinant of A is equal to, since the matrix A given, we can choose the first row and the first entry plus, then minus plus. Then 3 in bracket, first column and first row will be cancelled. Then 6 times 5 is 30 minus, and 4 times 7 is 28. Then minus, the second entry is negative 2. Negative of negative 2 will be plus 2. Then 0 times 0 minus 0, and everything is 0. The same thing, plus 8 times 0, everything will be 0 here. So here the difference 2 times 3 will be 6. So the answer will be 6 square, that is 36, which is B. Next question. Matrix M is given. Again, it is a 3 by 3 matrix, and then A transpose times M is equal to 2 times identity matrix. And A is a 3 by 3 matrix. Then what is the value of determinant of A? We need the determinant of A. Here what we can do, we can take determinant both sides. And this is the same as determinant of A transpose times determinant of M, which is equal to this constant. When you take it out, since the order is 3, it will be 2 cube times determinant of I. When there is a constant as a coefficient of a given matrix, when you take out from the determinant or from the absolute value, it will be taken out as an exponent of the degree of the given matrix. Since they are a 3 by 3 matrix, the 2 will be taken out as 2 cube. If it is 2 by 2, it will be 2 square. Then don't forget, again, determinant of A is equal to determinant of A transpose. So in place of A transpose, I can write determinant of A times determinant of M is equal to just 8. Again, determinant of identity matrix is equal to 1. Don't forget that. Then, since we are calculating or solving for determinant of A, we can divide both sides by determinant of M, determinant of M. Then this will be cancelled out, and determinant of A will be 8 over determinant of M. But the determinant of M can be calculated from the given, which will be 10. We can calculate and check, but let's do it, okay? The determinant of M will be, again, like we did before, we can select the first row and first entry plus, minus, plus, and the first entry 0, 0 times whatever is 0, forget it. Then minus 1 times, because the second entry, and cancel the second column in the first row. Then 3 times 4 is 12. 12 minus, and 5 times 0, it's just 0. Plus, again, the last entry is 2, and cancel the last column. 3 times 2, 6, plus 5. It will be plus 5. Then here, when you add 11 times 2, 22. Here it will be negative 12. Negative 12 plus 22 is 10. This is determinant of M. Therefore, this is equal to 8 over 10, which is 0.8, and the answer is C. Next question. If A is a square matrix of order 3 and determinant of A is given 5, then what is the value of the determinant of A times adjoint of A? this is equal to the determinant of A times determinant of adjoint of A. This time, since we have determinant of A, we need to get the determinant of adjoint of A only. But the determinant of adjoint of A is equal to the determinant of A the power of n minus 1. N is order of the matrix A. This formula can be proved. It's very simple. The proof will be from A inverse is equal to adjoint of A over determinant of A. Remember this rule, this formula. Then from this we can multiply crisscross. Then adjoint of A will be determinant of A times A inverse. Then if we take both sides determinant, this is what we need, determinant of adjoint A. Then what will happen, since this is a constant, when you take it out, it will be determinant of, as it is constant, as it is a power of n times what remains, the determinant of A inverse. The determinant of A inverse is just 1 over A, 1 over determinant of A. So we can simplify and write this one, determinant of A, the whole the power of n minus 1. This is the adjoint of A. Therefore, now we are here, the determinant of A times determinant of A, the power of 3 minus 1 we can write here, because the order is 3 here. Therefore, the determinant of A is given 5 times 5 the power of 3 minus 1 will be 2. So this is the same as 5 cube, which is 125. The answer is C. Next question. If let A be a 3 by 3 matrix and determinant of A again it's given, which is equal to -2. And then what is the value of the determinant of adjoint of A? We already proved determinant of adjoint of A is the determinant of A the power of n minus 1, which is the determinant of A the power of 3 minus 1, which is -2 the power of 2, which is 4. So the answer will be D. Next question. If A is a 3 by 3 matrix and determinant of A which is given to us 5, then we are asked to find the determinant of 2 times A transpose times A, which is equal to 2 cube times determinant of A transpose times determinant of A. The number 2, when we take it out, it will be cubed since the order is 3, which is equal to 8 times determinant of A square. These two are the same. So in place of determinant of A transpose, we can write determinant of A. Then when you multiply, it will be squared, which is equal to 8 times determinant of A is 5 square. So it is 8 times 25. When you multiply, it will be 200. So the answer will be A. Next question. For this system of linear equation containing alpha and beta as a constant, and the determinant of the coefficient matrix is -5. Don't forget, determinant of coefficient matrix means we are given the D, which is -5. According to Cramer's rule, the D means the determinant of the coefficient matrix. Then what is asked? What is the value of x, it says. We know that x is equal to dx over d, according to Cramer's rule again. The d is already given, which is -5. Let's find the dx. When you say dx, what to do? The first column will be replaced by the constant here. -5, 5, and 0. The rest column will be taken as it is. 2, 1, 0. Beta 3, 1 will be taken. Let us find the determinant of this. So what to do? Choose the first row again, then plus, minus, plus. So -5 in bracket. Here I'm going to cancel the first column, then 1 times 1, 1, minus 0 remain, minus 2. The second column will be cancelled again, 5 times 1, 5, again minus 0, 0 times 3, plus the last one is beta multiplied, the last column will be cancelled, and 5 times 0, 0, everything will be 0 here, cancel out. So what left? -5 minus 10 left, which is -15. I have got dx. Now since we are looking for x, we state the formula already. The dx is negative 15 over d or determinant of the coefficient matrix, which is d given negative 5, which is equal to 3. The answer will be A. Next question. The system of the equation, what's given here, it has no solution. So what must be the value of A and B? That's the point. So first of all, give a given system of linear equation to have no solution according to Cramer's rule. The d must be 0, but the dx should be different from 0, and the dy also no 0, and the dz also has to be different from 0. So this is a case. So first of all, let us find the d which is equal to 0. Let's make the d 0. The d means the coefficient, the determinant of the coefficient matrix, which are 1, 1, 1. You can see from here. The coefficient matrix is the coefficient of x's written first column, second column the coefficient of the y, 1, negative 2, and 4, and the last column is the coefficients of the z, negative 1, 0, and negative a, which is equal to 0. It must be 0 to have no solution. So when you calculate this determinant, it will be 2a minus 4 will come, which is equal to 0. So when you reshuffle, the a value will be 2. So to have no solution, this system of linear equation, first of all, a must be is equal to 2. So which choice containing this? Choice A and choice D. A must be 2. Okay, but it's not enough. Now let us find dx which is different from 0. This is the d. The dx is equal to, first column will be substituted by the constant, which is 6, negative 4, and b, and the second column as it is will take 1, negative 2, and 4, and the last row as it is negative 1, 0, and 2 we can take, because the a value already we got it 2. So a must be negative 2. So when you this is equal, this should be different from 0. So when you calculate the determinant of this result, so when you find the determinant of dx, we will get 32 minus 2b, which is different from 0. Then when you reshuffle and solve for b, b has to be different from 16. So this system of linear equation will not have a solution if and only if a must be 2 and the b must be different from 16. So the answer must be D. Once to repeat, see, when we are applying Cramer's rule here, to have no solution, the coefficient matrix D must be 0 beginning, and then the other should be different from 0. If you solve one of it, it is enough. We can make dx is different from 0. But if all 0, d 0, dx also 0, the dy 0, and the dz 0 means it will have infinite solution. Don't forget that. Next one, the determinant of a 2 by 2 matrix here, negative 3x and 3x4, it's given is equal to 15. Then what is the value of x, it says. So let us find the determinant here. Negative 3 times 4 is negative 12 minus 3x times this one negative x. 3x times negative x will be plus 3x square, which is equal to 15 given. So 3x square is equal to, when you shift the negative 12, it will be added 27, then divide by 3 both sides. So x square is equal to 9. If we put both sides in the square root, the x value must be plus or minus 3. So the possible values of x, it is 3. The answer is C. Next question. Consider the following system of equation, again given. How much should be the value of k so that the system has a solution? Again here, the system to have a solution, we can apply elementary row operation here. What to do? Let us take the argument matrix 1, negative 2, 1, 1, negative 1, 1, 1, 3, and again 3, negative 5, 1, and k. These are augmented coefficient matrix. Then let us try to reduce and let us try to check. So when we are applying here elementary row operation, what we can do, we can make the second entry here and this one 0. To make the second row first entry 0, we can add first row with second row directly. So what I can do, R1 plus R2 will give us R2, and again to make this 0 I can multiply the first row negative 3 times R1 plus R3 will be R3, and let us see the result now. I'm going to do two things at the same time. It will be the first row will be as it is, 1 negative 2 1 1 will go down, and then I will add 1 plus negative 1 will be 0, and here negative 1, 2 and 4, and the last one I will multiply by negative 3 then add, which will be 0. Negative 3 times negative 2 6 plus negative 5 will be 1 again. Negative 3 times 1 is negative 3 plus 1 will be negative 2. Again negative 3 times 1, negative 3 plus k is negative 3 plus k. Okay, again this time again I can add second row and the third row, because the two we can make more zeros here. When we're applying elementary row operation or row reduction method, we are trying to make as much as many zeros. So what to do now? R2 plus R3 will go to R3, so the result will be the first row again it is the same, 1 negative 2 1 1, we can take as it is, and the second row again the same, 0 negative 1 2 4. Okay, then the last one we are going to add the two rows. 0 plus 0 will be 0, and negative 1 plus 1 will be again 0, and 2 plus negative 2 will be 0, and 4 plus negative 3 plus k will be 1 plus k remain, because we are going to add the constant numbers. 4 plus negative 3, you know, it's 1. Now this system of equation, now look the last row. The last row everything is 0, everything becomes 0. If everything 0, it will be many solution. If one of the row become everything 0, we can say it has many solution. If 1 plus k also becomes 0, it will be many solution. But if 1 plus k is different from 0, it will have no solution. But we are almost failing here. It says it has it says what must be the value of k, so that the system of this linear equation has a solution. Has a solution means at least it has to have many solution cases. There will be two possibilities here. Either it has many solution or no solution, but it is not no solution case. So many solution means 1 plus k must be 0. 1 plus k is equal to 0 means when you reshuffle, the k value must be negative 1. To have this system of linear equation to have a solution, the k value must be negative 1, so the answer will be D. Next question, it is probability. What I say, different code, each of which consisting of 5 characters, are to be generated in such a way that the first 2 characters are any of the English letters from A to Z. Now we are going to make 5 characters, 1 2 3 4 5 characters. The first 2 will be any English letters, means we have 26 times 26 chance, and the remaining 3 are any of the digits from 0 to 10. From 0 to 10 we have 10 of the number, either of the 10 numbers. We have 10 possibilities, so we can say 10 times 10 times 10, because it doesn't say no repetition, so we can repeat. So we are making 5 characters, as you see, but the first 2 are any English letters. English letters from A to Z are 26, so 26 times 26 chance we have, and the last the 3 will be either of the digits from 0 to 9 will be 10 each of like all of them are 10, so 10 chance we do have. So when you multiply, it will be 676,000 easily. 10 times 10 times 10 will be 1000, forget it. 26 times 26, you know, it's a perfect square number, 676. then the 3 zeros will be added. So the answer will be C. Next one, again it is a probability. Suppose that 3 letters A, B and C and number digits are to be used to car plates in a small town. How many different plates can be formed in a total that contain 1, 2 or 3 letters and then followed by 3 digits? Digit, I mean 1 letter and 3 digits, or 2 letters 3 digits, or 3 letters and 3 digits. This is a possibility because here the secret is here. It says 1, 2 or 3 letters and then followed by 3 digits. Followed by 3 digits means we can take any digits. So 10 times 10 times 10. The digits are 10 from 0 to 9. 0, 1, 2 until 9. So 3 digits will be from 0 to 10, 9. I mean, yes. So we have 10 chances here. So followed by 3 digits means the 3 places will be filled by any of the digits. So we have 10 chance each of them. 10 multiplied by 10 times 10, which will be 1000 each of them. So how many thousand? The first, the second one, how many thousand, and the third one, how many thousand? Then we'll add it, the total possibilities we are asked. Since it says 1 letter and 3 digits, or 2 letters and 3 digits, or 3 letters and 3 digits. So when it says 1 letters, how many chance we have? Only 3 chance. So it will be 3000. When you have 2 letters means 3 chance again we do have. It will be 9000 because 3 times 3. 3 letters and 3 digits when it's 3 times 3 times 3, which will be 27,000. When you add them, it will be 39,000. Total possibilities of forming a plate number will be 39,000, which is C. Next question. In a box contains 2 white balls, 3 blacks and 4 red balls. In how many ways 3 balls can be drawn from the box if at least one black is to be included? So what are we supposed to do here? If at least one black is to be included, at least one black means the possibilities of the selection will be 2 white and 1 black, it's okay. 2 white and 1 black, or 1 white and 2 black, it's okay. Because at least 1 black means even 2 black it's okay, 3 black also it's okay. So it can be 2 white and 1 black, or 1 white and 2 black. This is a combination with white. With red, 2 red and 1 black, again it's okay. 2 red and 1 black, plus 1 red and 2 black, it's okay. The other possibility, 1 white, 1 black and 1 red also, it's okay. Still there is 1 black here at least, or 3 black. These are the total possibilities. Exhaustively, when we see the possibilities of including at least 1 black, will be 2 white and 1 black, or 1 white and 2 black, 2 red and 1 black, 1 red 2 black, or white red black, or the 3 blacks. These are the total possibilities. So let us combine this. 2 white means 2 combination 2, and 1 black is 3 1. This is one possibility, plus 1 white means 2 combination 1, and 2 black means 3 combination 2, plus 2 red for combination 2 and 3 combination 1, or for combination 1 and 3 combination 2, plus still 1 white, 1 black, 1 red means 2 1, 3 1 and 4 1. From each 1 1 1 combine. This is one possibility, plus all the 3 black means 3 combination 3. Now you have to be systematic and calculate. 2 combination 2, you know it's 1, and this is 3. 2 combination 1 again 2, and 3 combination 2 3, and 4 combination 2 is 6, and 3 combination 1 3. Here it's 4 3, and this is 2 3 and 4, and 3 combination 3 is just 1. So what's left now? 1 times 3 will be 3 plus, and 6 plus, here 18 plus 12 plus, here 2 times 3 6 times 4 24 plus 1. So when you add these two, 30, and again 6 and 24 30 plus 30 plus 30 60, and 3 plus 1 is 4, together will be 64. So the answer should be A. This is the total possibilities of selection. Next one, a student need to select 3 books from 3 mathematics and 3 physics and 4 history. What is the probability one of the is mathematics and the other are either physics or history books? Okay, again, what to do here? So at least one of the book is mathematics, means not at least, actually it says what is the probability one of them is mathematics. That means 1 math and 2 physics possible, plus 1 math and 2 history possible, and 1 math 1 history and 1 physics also it's possible. This is a possibility, divide by, because since we are asked the probability, the total number of books are 10 combination 2, selecting 3 from the 10 books. 10 combination 3 is 120. No need to worry about this one. So let us combine the upper part. The upper part, when we say 1 math 2 physics, it will be 3 combination 1, and 2 physics means 3 combination 2, and 1 math 2 history means again 3 1 and 4 2. Math history physics 1 1 means 3 1, again 3 1 and 4 1. So what you can do, 3 1 it is 3, and 3 2 also 3. 3 times 3 is 9, plus 3 1 again 3, and 4 combination 2 is 6. 6 times 3 will be 18, plus 3 combination 1 again 3, and here also 3. 3 times 3 is 9, again this is 4. 9 times 4 is 36, divide by 120. When we add the upper part will be 63, divide by 120. We can simplify by 3, it will be 21 over 40. So the answer or the probability will be C. Next question, if vector v given I plus 3j and a, which is 1 comma negative 1, and d 2 comma x also given, then what the value of x, so that a is parallel to AD is parallel to v, vector AD is parallel to v. First of all, what's AD? AD means we are going to subtract A initial, D terminal. So from the terminal we'll subtract the initial. So 2 minus 1, which will be 2 minus 1 is comma, okay, x minus negative 1 will be x plus 1. So this is the same as 1 comma x plus 1. This is AD. So if AD is parallel to V, what to do? The vector AD, okay, the y component divided by x component, that is x plus 1 divided by 1, it must be equal to the V, the y component is 3 and the x component is 1, 3 over 1. Then when you multiply by crisscross, x plus 1 will be 3, so x must be is equal to 2, so the answer is B. Next question. Vector u, it's given 3i plus 2j, and vector v, negative 6i in the I minus 4 in the j. Then what's the angle between the two vectors? U dot v means the same as magnitude of u plus magnitude of v times cosine of theta. So the theta will be, if you divide both sides, magnitude of u times magnitude of v, this will be cancelled out, so cos theta will be u dot v over magnitude of u times magnitude of v. But u dot v, we can simply get it by multiplying the corresponding component, x component with x component, that's negative 18, plus again y component with y component, that's negative 12. When you add it, it will be negative 30. This is u dot v. And again, magnitude of u, 3 square plus 2 square, we can add in the square root. 3 square 9 plus 4, that is 13. Magnitude of v also, we can add in the square root again. 36 plus 16, which will be 52 in the square root. Okay, this is 52 in the square root. Okay, now let us use the space again. So since we have everything here, let us substitute to get the theta. U dot v is negative 30 over magnitude of u is radical 13 times radical 52, which is negative 30 over, we can multiply the two together in one square root of 13 times 52 by itself is 13 times 4, which is negative 30 over 13 times 13 is 169. From the square root will be 13, and 4 from the square root will be just 2. Then when you simplify by 2, 1 this by 2, 15, then cos theta is equal to negative 15 over 13. But here, when we are calculating, at some point we made some mistakes. U dot v, when you say u dot v, we are going to multiply corresponding values, like first order with first order, that's negative 18, plus the y component with the y component, that must be negative 8. So when you add, this will be negative 26. So everywhere here we have to correct it. This is 26, negative 26 is also 26. So when you get back and correct this part, what will happen? The result will be negative 26 over the down part as it is, 13 multiplied by 2. Then we can simplify here by 13 1, this by 13 times 2 is 26, so everything will be cancelled. What remain? Negative 1. So cosine of theta is equal to negative 1 means the theta value, it must be pi, or theta value is equal to negative pi. Either of the two will be the answer, so the answer is A. Next question. The vector A is given 4 in the I minus 3 in the j, and u is a unit vector such that magnitude of A plus u the whole square is equal to 27. Don't forget, u is a unit vector means magnitude of u is equal to 1. Then what is the cosine of the angle between A and u? First of all, what means magnitude of A plus u the whole square? This is equal to magnitude of A square plus 2 times A dot u plus magnitude of u square. This is given 27 plus magnitude of u square. Okay, magnitude of A, we can find it. Magnitude of A, we can square each of the component in the square root. 4 square plus negative 3 square, 16 plus 9, which will be 25 the square root, that's 5. So 5 square 25 plus 2 times A dot u means magnitude of A times magnitude of u times cosine of the angle theta between A and u plus 1, which is equal to 27. Now this time we can add 25 plus 1 is 26. When you shift it, it will be subtracted. So 2 times what remain here, magnitude of A that is 5 times magnitude of u, which is 1. Cosine of theta is equal to 1 remain. How this one comes? Remember, 25 plus 1 is 26, so when I shift it, it will be minus 26 here. So 1 remain. 2 times 5 is 10, so I can divide both sides by 10. When you divide, cos theta will be 1 over 10, or 0.1. We are asked to find the cosine of the angle between A and U, which is 0.1. The answer will be A. These are some of the questions that I prepared for today. Hopefully I'll get back with additional videos. Thank you for watching. Don't forget to share to your friends.